The US military figured out a long time ago that you could stop a bullet with a bag of dirt. And somehow, we still pay $195 a square foot to build houses out of wood. Let me put that another way. The average new home in America costs somewhere around $195 per square foot to build. When you include everything: framing, foundation, materials, contractor, that's $390,000 for a 2,000 square foot house. And that house, if it catches fire, burns to the ground in minutes. If a serious flood hits it, it warps and rots. If an earthquake shakes it hard enough, the wood frame cracks and collapses. This is what we decided is normal. Now here's the thing. There is a building method where people have put up a small house walls, everything for somewhere between $3 and $12 per square foot in materials. Not labor estimates, not theoretical calculations. Real people documenting real builds. The walls of that structure can stop a bullet. In Nepal, 55 of these buildings survived a 7.8 magnitude earthquake in 2015. While every concrete building around them cracked or collapsed. The U.S. Army uses the same principle for its field fortifications. NASA looked at this technology for building habitats on the moon. And if you walk into most building departments in this country and tell them you want to build with it, they'll look at you like you've lost your mind. It's called Earthbag Construction. And the story of where it comes from is genuinely strange. The basic idea has been around for over a century. Armies have always known that a bag of sand stops bullets and shrapnel. In World War I, British and German trenches were reinforced with sandbags. Those sandbags were intended to be temporary. Some of them are still standing. But Earthbag Construction, as an intentional building system for permanent housing that came from one man, and the path he traveled to get there, is not what you'd expect. Nader Khalili was an Iranian-born architect, California licensed since 1970. In the mid-70s, he walked away from his practice, sold his share of the firm, and spent 5 years traveling through Iranian desert villages on a motorcycle studying how people had built with earth for centuries. He came back to the United States in 1981 with a completely different idea of what a building could be. In 1984, NASA put out a call. They were thinking about long-term human settlements on the Moon and Mars. And they wanted unconventional ideas for how to build structures up there. You can't ship lumber to the moon. You can't mix concrete without water. But you can fill a bag with whatever material is locally available lunar dust, Martian soil, gravel, dirt, and stack it into a wall. Khalili presented his Earthbag concept to NASA that year. He called his particular system Superadobe. The idea was simple. Fill long tubes or individual bags with earth. Layer them in coiling courses like a beehive. Run barbed wire between each course to lock them together so they can't slide apart. And the whole structure becomes a compression arch. It holds itself up. No rebar inside the walls. No concrete column hidden in the center. Just earth under pressure, locked by wire, shaped into a dome. NASA was interested. Khalili came back to California and started building. His nonprofit, the California Institute of Earth Art and Architecture CalEarth, is still operating today in the Mojave Desert. The structures he built there passed California Earthquake Code, a state known for being the most demanding in the country on seismic requirements. Earthbag passed. So let's talk about why this actually works, because it's physics and not magic. When you fill a bag with moist soil or sand and tamp it flat and tamping is important, we'll get to that you're creating a dense, heavy, compressed block. A typical Earthbag wall ends up being around 14 to 18 inches thick. That's mass. A lot of it. And mass does things that lightweight wood framing simply cannot do. It stores heat. When the sun hits an Earthbag wall all day, the wall absorbs that heat slowly and releases it back into the interior at night. In hot, dry climates, the American Southwest, the Middle East, large parts of Africa and South America This is the difference between a house that stays comfortable at 68 degrees inside when it's 105 outside, and a wood frame house that just transfers the heat straight through. People who've lived in Earthbag homes in Arizona, New Mexico, and Turkey consistently report the same thing. Once the walls are up and plastered, the temperature inside barely moves. It stops bullets. This is not a metaphor or a sales pitch. This is documented. A wall packed with dense, compacted earth simply absorbs kinetic energy. The Army has known this since the Civil War. In 2006, controlled load-bearing tests on polypropylene earth bags concluded that Earthbag walls showed significantly greater compressive strength than conventional wood stud frame construction. Results that have since been cited in multiple independent structural engineering studies. It survives floods. When the Mississippi floods, sandbags are what people use to hold back the water. An Earthbag wall is, essentially, a very long permanent sandbag. Builders in hurricane zones have put up Earthbag structures and walked away from storms without serious damage. The walls don't move. And the earthquake data from Nepal is worth sitting with for a moment. In April 2015, a 7.8 magnitude earthquake hit Nepal. It killed nearly 9,000 people. Concrete buildings cracked and pancaked. Traditional adobe structures, just mud without any reinforcement, collapsed entirely. 55 Earthbag structures in the affected zone survived without structural damage. Not minor damage. No structural damage. The barbed wire between courses creates what engineers call a flexible tensile system. The wall can move a little without failing. Concrete can't do that. It's rigid, and then it's rubble. Now let's get real about the cost, because this is where the conversation usually goes sideways. The number you'll see thrown around most is somewhere between $3 and $12 per square foot for the wall material itself. Here's what that actually breaks down to. For a basic 400 square foot structure, a small cabin, a workshop, a studio you're looking at roughly $80 to $200 for the bags themselves, usually polypropylene grain bags or purpose-made Earthbag tubes. 5 rolls of barbed wire, about $60 to $120. Gravel for the rubble trench base, a few $100. Foundation and bond beam at the top, a few $100 more. Plaster inside and out to seal and protect the walls, another $400 to $1,500. Total materials for a small structure built owner labor, $1,600 to $5,500. That's the real-world documented range from people who've actually done it. One person built a 176 square foot roundhouse in a rural area for $1,000 flat. Documented builds from the same period in low-cost regions, parts of the Middle East, Central America, and rural Asia consistently land in the $4,000 to $7,000 range for a complete small structure including roof and floor. Compare that to the $195 per square foot national average for conventional construction. A 400 square foot conventional structure at that rate would run you $78,000. You're not building the same thing. Obviously, the finishes aren't the same. The plumbing and electrical aren't included in either number. But the walls, the structure, the shell that determines whether your building survives a storm, or a fire, or a flood. That part costs a fraction. There are real limitations here, and I'm not going to skip over them, because that would be doing you a disservice. Earthbag is physical work. Lifting and tamping bags at shoulder height and above is demanding. Most serious builds involve multiple people or some kind of material lift. Going it completely alone on anything bigger than a small shed is genuinely hard, not impossible, but hard. It is not a good insulator in cold climates. The R value of compacted earth is roughly R1 per foot. A 15-inch thick earthbag wall gives you somewhere around R2. That's about the same as a double-pane window. In Maine, in Minnesota, in Canada, that wall is not keeping your heating bill down. The thermal mass works brilliantly in hot, dry climates, where the temperature swings between day and night are large. In consistently cold climates, you need to pair it with exterior insulation to get the performance you want. And then, there's the building code problem. And this is the part that keeps this technique stuck in the margins. Earthbag is not in the International Building Code. It is not a listed approved method the way wood frame, concrete, and steel are. Which means that unlike conventional construction, where the inspector simply verifies you follow the code, Earthbag construction puts you in a position where the building official has to make a judgment call. Some of them have. The structures at CalEarth pass California Seismic Code. Multiple independent structural engineering studies have validated the material. Some counties, particularly in the rural American Southwest, have approved earthbag builds. But walk into most suburban building departments with earthbag plans, and the most likely response is, get an engineer to stamp this or come back with something else. There are counties in the U.S. with few or no building codes. Parts of Texas, New Mexico, Colorado, Missouri, and others where owner-built structures on your own land exist in a much more permissive regulatory environment. If you're building in one of those places, the code barrier largely disappears. If you're building in a jurisdiction with active code enforcement, you either need an engineer who's willing to work with alternative materials, or you need to accept that the permit process is going to be a conversation rather than a transaction. What the concrete and lumber industries have, that Earthbag does not, is a place in the model building code. That didn't happen by accident. It happened through decades of industry involvement in standards writing processes. When something isn't in the code, it's not automatically because it's unsafe. Sometimes it's because nobody who benefits financially from the method has the resources to push it through the approval process. Earthbag has been validated by independent engineering research, by CalEarth, by engineers responding to disasters in Nepal, Haiti, Pakistan, and Mexico. The method has been proven in the field multiple times over. It just hasn't had the lobbying budget. Here's what the actual process looks like if you want to try it. You start with your foundation. A rubble trench is a natural pairing with earthbag walls. The drainage principle works beautifully at the base of an earthbag structure because it keeps ground moisture away from the bags. First course of bags goes in filled with gravel, not soil. Gravel doesn't wick moisture upward. Every course after that can be filled with the soil you dug out of the site itself in most cases. The building grows from the ground it sits on. You fill each bag about 2/3 full, fold the open end under, set it in place, and tamp it flat and firm with a hand tamper or a weighted pipe. Each course is offset from the one below like brickwork. Between each course, you run 2 strands of barbed wire. The wire acts as a mechanical bond between courses and provides the tensile strength that allows the wall to flex rather than crack under stress. Windows and doors get rough frames, called bucks, set into the wall as you build up. When the walls reach the desired height, you pour a reinforced concrete bond beam across the top dash. This is a continuous ring of concrete with rebar that ties all the walls together and gives you a level, square surface to attach your roof structure to. Then the whole thing gets plastered, usually a scratch coat, a brown coat, and a finish coat, inside and outside. The plaster seals the bags from UV light. Polypropylene degrades in sunlight and from moisture. Once plastered, an earthbag wall looks like a smooth adobe or stucco wall. You'd have no idea what was behind it. The whole process from foundation to plastered walls on a small structure. If you're building with 2 or 3 people and not rushing, typically runs about 6 to 8 weeks. Not 6 to 8 months. Weeks. There are people building these right now in Arizona, in New Mexico, in Turkey, in Nepal, in Haiti. In a dozen countries where conventional construction is either too expensive or too fragile for the local conditions. If you build with Earthbag or you're planning to, or you're curious about a specific part of the process, put it in the comments. The people who've actually done it tend to be genuinely useful to each other. And it's one of those topics where real experience matters a lot more than theory.